Oh, 6.1, higher roots. Let's go ahead and start a new chapter. We're going to be dealing with higher roots. What you guys have been working with already that you're familiar with are square roots, like the square root of 25. Now here's something that you might not know is there's always been an imaginary little 2 here, and that actually represents square rooting something. All right, and we all know the square root of 25 is just 5 because it's what times itself gives you 25. But we know the answer is 5. But when you're solving an equation, if they ask you to do something with a square root, you have to remember to do a plus and a minus, because if you know, a negative 5 times a negative 5 is also 25. So in this case, we have two specific answers. 5 times 5 is 25, and negative 5 times negative 5 is also 25. And then a couple of chapters back, we did negative square roots too. And whenever you have a negative underneath this square root, you have to remember the I. So we have plus or minus 6i. And then, of course, sometimes they don't work out perfect, like square root of 24. That's not a perfect square root. And so when I ask you to simplify it, you have to break it down. Here's my showing your work. 2 times 12 is 24. 2 is a prime number, so I circled it. Break down the 12. You get 2 times 6. Again, 2 is a prime number. You circle it. Break down the 6. You get 2 times 3. And now both of those are prime numbers. And again, the way you simplify it is you look for pairs. These two guys make a pair. And then these two are actually loners. They don't have a pair, so they actually stay on the inside with the 2 and the 3. All right, and here's our final answer. Plus or minus 2 square root of 6. You just multiply the 2 and the 3 together. Okay, so that was all review of square roots. Let's bump up the level of difficulty. Let's move on to cubed roots. Cubed roots. In this case, we're asking ourselves, what times what times what 3 times gives us 8. And most of you guys can do that in your head. It's 2 times 2 times 2. Because 2 times 2 is 4, and then times 2 is 8. Notice that it doesn't work with plus or minus with this one, because if we tried a negative 2 times a negative 2, that actually gives you a positive 4, but then times another negative 2 gives you a negative 8. And so it doesn't work with cubed roots. So there's only one answer when we do cube roots. What about a cube root of negative 125? Now in the last example with square roots, we had to use imaginary numbers. But with cube roots, and actually with all of the odd roots, like the 5th root, the 7th root, you won't have to do imaginary numbers, because it turns out that negative 5 times negative 5 times negative 5 is negative 125. Positive 5 doesn't work. Positive 5 times positive 5 times positive 5 gives you a positive 125. But negative 5 works. And then even if you tried a 5i, the 5i doesn't work either. So in this case, you only have one answer. And then, of course, when it's not perfect, like 48, we break it down. And then there's lots of ways to break it down, but I chose 8 and 6. Break it down more. The 3, the 2, and the 2 are prime numbers, so I circled them. And then break down the 4, and that's 2 and 2. All right, in this case, with cubed roots, you have to be a little bit careful. With cube roots, you don't look for pairs. you look for triplets now. And so here are triplets. So you write them once. And then these are loners. They don't have triplets. So you write them on the inside, the 2 and the 3. And then don't forget, it's not a square root, it's a cubed root, so you put a little 3 in there. And here's the final answer. Oh, it's a little bit messy. Let me erase it. There it is, 2 cube root of 6. Let's go on up, higher. Fourth roots. The fourth root of 625, it's what times what times what times what? 4 times to get 625. And you can do it in your head. 5 times 5 times 5 times 5 gives you 625. And then negative 5 times negative 5 times negative 5 times negative 5 gives you 625 positive as well. So if you notice, there's a pattern. Square roots, fourth roots, sixth roots, you're going to have plus or minus, but not with the odd roots, only the even roots. Now what about imaginaries? So when you have a fourth root of negative 81, if you thought, well, let's just do the 81 for now. The fourth root of 81, that's 3 times 3 times 3 times 3. That's 81. But then if you tried a negative 3, that doesn't work. If you tried 3i, it doesn't work either. All right, so it turns out that these ones have no solutions. They actually do have solutions, but it requires a lot of calculus to solve these out. So for now, when you have anything higher than a square root, we're just going to go ahead and write no real solutions. Ooh, and then if you have something really big, we have to branch it out. I didn't branch it out because there's a lot of branches. But remember, we're not looking for pairs, we're not looking for triplets, but we're looking for quadruplets now because it's fourth root. And it turns out we have 4 4s, and then the loner is going to be, I think, a 3 and a 5 were the 2 loners. All right, so if you broke down the tree, you'll see. All right. Let's do some tricky ones. And by tricky, I mean I just put in some X's and some Y's. Okay? But still pretty doable. Let's focus on the number first, the 2160. Let's break that down. I chose 5 times 432. 5 is a prime number, so I circle it. Break down this one. Break down both of these. Prime number 2, prime number 2. Break down more. Prime number 3, prime number 2, prime number. Break down the 9. And then you get those. All right, so that's a lot of breaking down, but in this case, we are looking for triplets. So we have these guys. I'm going to write them once. We have these triplets. I'm going to write them once. And then I think we have a few loners. Here's this loner, and here's this loner. So it stays on the inside, the 2 and the 5. And don't forget to write this little 3 in the little corner to let you know that it is a third root or cube root. Here's the answer for just the number part. The 3 and the 2 makes a 6, and then the 5 and the 2 makes that 10. Okay, I'll erase all of this. Let's focus on these X's and Y's now, actually just the X's. It looks like you have 4 X's on the inside. Now, if we follow the same rule and we look for triplets, there's actually 1 triplet. Here, I'll write it out. There's X, there's X, there's x, there's x. These guys make a triplet. We write it once. This one is a loner, so it stays on the inside. And don't forget that little cube. And so to incorporate this into that answer, you just put the x that's on the outside and the x that's on the inside. All right, so there we have the 1x that made the triplet, and then this 1x was the loner. Okay, now let's do the y's. Same way. There's 8 y's. I don't want to write out all 8 y's, but how many groups of 3's can I make? I can actually make 2 groups of y's, and then what's left over is just 2 more. Okay, so let's incorporate that into our answer. And there we have it, the final answer. 6xy squared cube root of 10xy squared. All right, that is all we have for today. Go ahead and enjoy the homework.